All right, guys, we've got a little more recursion here to go over today. Like I said, I'm just going to keep hitting this and trying to explain it in different ways. All right, today we're doing it's actually night. It's Wednesday night. We all had class today. I showed you all um, the recursion where it adds the numbers. You put in a number and it added like 50, 49, 48, all the way down to 3210. Okay, this is one that's actually a famous mathematic one. It is um, the Fibonacci series, Fibonacci sequence, and it's basically a sequence where the numbers add the two numbers before it. So the first sequence is 0, then there's 1, then there's another 1 because it adds the 0 and 1 together. Then 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. 5 plus 8 equals 13. 13 plus 8 equals 21. 21 plus 13 equals 34. 34 plus 21 equals 55. All right. The way this sequence works, this 0 is the 0th term. This works a lot like arrays. This 1 is the first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. All right. This 55 is actually a famous one for testing your code because you enter a 10 into this just to see if it equals 55. All right. This is pretty simple. This is defined. You enter a number, and if I entered a 10, I would end up with a 55. It's the 10th term. If I entered a 5, which we're going to actually do the math on, it's going to end up being a 5. The 5th term is a 5. Okay, you enter a number, it puts it into the Fibonacci function, and it equals a total and sees it out. Okay, so Fibonacci, you're just going to enter an integer inside of it. All right, here's the crux of it. Here's the actual Fibonacci function. So I put a number into it, and say we just for purposes of a demonstration, I put a 10 in, Fibonacci 10. So if numbers less than 2 or greater than equal to 0, basically we want to get a 0 or 1, we return that number. All right, that's our base case. I've mentioned the base case before. So all zeros and ones, it just returns that number. So if I enter a 1, it's going to return a 1. If I enter a 0, if I enter a 0, it's going to return a 0. Otherwise, the number is going to be above that. So if I put in a Fibonacci, if I entered Fibonacci 10 here, it's going to return Fibonacci 9 plus Fibonacci 8. So you can see where this, if you use a larger number, it trees out. So for my explanation, I'm only going to use a 5 because I've only got so much space down here to explain it. All right. Then each one of those will call, if this was, like I said, this is Fibonacci 9 here, it's going to branch off and call Fibonacci 8 and 7. And this is Fibonacci 8, it's going to call 7 and 6. So you can see how it branches off. All right. What we're going to try to do is work through this and figure out what F5 equals. All right. The easy ones are 0, I'm just going to, for the sake of room down here, I'm going to call it F. F0, so F0, it's going to return 0. So we know that this equals 0. Also, I know that F1, if I entered a 1 here, it's just going to return a 1, the number that I entered. So F1 is 1. All right, now let's figure out what F2 is. All right, check in these branches here. F2 is going to be F1 plus F0. So F0 is 0, F1 is 1. So that means F2 is actually going to be 1 also. All right, let's see what F3 equals. So here's F3, and you can see from this tree, it equals F2 plus F1. So F2 equals 1, F1 equals 1. So that means F3 equals 2. All right, F4. All right, here's our F4. So F4 equals F3 plus F2. So we know that F3 equals 2 and F2 equals 1. So that means F4 equals 3. Now let's figure out what F5 is. And see how we're working our way up through here? This is sort of like what goes on when it's coming out of recursion, when you're popping these off the stack doing the math. All right, now here's F5. F5 is going to be F4, which we know is 3, plus F3, which we know is going to be 2. That makes F5 equal 5, and we ran this earlier, and we saw that was the case. All right. The problems I did in the last video and today in front of you, in front of the board, you could have probably done just as easy using arrays. And it probably would have been actually faster and less of a draw on your memory. But this one here is almost lends itself to where you'd almost, to do it neatly and nice and efficiently, you would have to use recursion. All right. So I kind of explained this different than I explained today's. Basically, you can see that you work your way down to the base cases and then work your way back up. That part, what I just said there, work down to the base cases, F1s and F0s. If you can see, I broke this all the way down to F1s and F0s, which were the base cases. And then I built my way back up to the F5, which was what I was testing right here, because I was going to enter a 5 right there. All right, give this a look over. My plan is to yet on Friday, when you all come into class, the beginning of class, go over yet another, I was going to say another Fibonacci, another recursive program, maybe a little more complex than this. Friday will be a work day. After that, everybody's going to need to finish up the programs. Didn't see a lot getting done on the programs. Guys, I can't stress enough, you're all not using the time in class well enough. All right. I've flipped this class so you can work on it, so you can ask me questions if you get stuck. And I see too much of using the class time as your social time and wanting to work on programs outside of class. I mean, that's just dumb. That's all. I mean, all I can say is it's just dumb. Utilize the time in class. Enjoy your time outside of class. All right. So this is Thursday's video for production day, and I will see you guys on Friday.